We're going to continue talking through Newton's second law problems. Make sure you've hit a refresh on your Google Slides doc because I kind of changed. I added a couple later on. Make sure you've got the most up-to-date version of the Google Slides. I'm going to keep chunking it into fairly short videos. I think that's easier for me technically and maybe less boring for you to watch at home. Let me know if you disagree. These first couple slides, you saw this already. Normally, in a normal world, I'd be doing these on the whiteboard, but here we go. Really what we're doing over and over again, and this is really the big outcome out of grade 11 physics, is that you can work F net equals ma. So I broke it into the three cases yesterday, or last week, I guess. We did what I called part one, which was horizontal, pushing, overcoming friction, things like that. Part two is all about working in the vertical. Before doing part two, before doing these problems, you should read through the document I posted on the normal force. That'll come up a bit later. The first questions don't really involve the normal, but go back and read the normal first. Our first question, this is a standard question. Read through this one. The standardness to it is these parts. All of these questions are exactly the same. They may not look like it, but from a forces perspective, they're exactly the same. Since for all three cases, it's not accelerating. So instead of doing the three little questions individually, they're exactly the same. Really, we just have to do it once. If you draw a free body diagram, let's say it's when it's stationary, if you want to think about it that way. A stationary elevator, it's going to have gravity pulling it down. Eventually, we can go one step farther. We know gravity is always the mass times 9.8. There has to be an upward force to keep it from falling. In an elevator, it's those cables holding it up, so often we call it F with a T, this T standing for tension. When the elevator is stationary, the forces have to be balanced. If the upward force were bigger, that would mean it's accelerating upward. If the downward force were bigger, that would mean it's accelerating downward. If it's stationary, that means it's not accelerating at all. That means the forces have to be equal. This one I made up a number of 400, so whatever 400 times 9.8 is. Double check, but I'm getting 3920. That's thinking through when the elevator is stationary. If we think through when the elevator is moving upward at a constant speed, if it's moving upward at 2 meters per second, it doesn't say it's accelerating. Since it's not accelerating, it's the exact same physics. If the upward force were bigger, then it would speed up and would go faster than 2. If the downward force were bigger, maybe it's going up but slowing down, so it would go from 2 and it would slow down. So when it's going upward at a constant speed of 2, the forces have to be the same, otherwise it would accelerate, maybe speed up or slow down. Similarly, when it's going downward at a constant speed of 2, if the upward force were bigger, that would mean it's actually accelerating upward, so it would be going down but slowing down. Or if the downward force were bigger, if it's going down at 2 but the downward force is bigger, that would mean it's speeding up. Since nowhere in this question does it say that it's accelerating, it went from stationary to up at a constant speed to down at a constant speed. Since it's never accelerating, those forces always have to be balanced. Now, if it's stationary, to get to, so the transition from being stationary to moving up at a speed of 2, that just, during that time where it goes from stationary to moving up at 2, then the forces would be out of balance and there would be some acceleration. But the way I worded this particular question, didn't ask about that time of acceleration, just what's happening when it's stationary, and then later on, what's happening when it's moving up at 2. Similarly, to go from moving up to going down, there would have to be the downward force would kind of have to win the tug of war, but the question didn't ask about that. Just if we're focused on when it's stationary, if we're focused on when it's going up at that constant speed and when it's going down at the constant speed, the physics is the same. The forces have to be balanced.